Have you ever wondered how computers think? I mean, they don't have brains like ours, do they? Instead of using words and numbers like we do, computers speak a special language called binary code. Imagine a world with only two numbers, 0 and 1. That's the world computers live in. Everything a computer does, from showing you funny cat videos to launching rockets into space, is all thanks to these two little numbers. But how can just two numbers be enough? That's what we're going to explore today. Get ready to dive into the fascinating world of binary and hexadecimal, the secret codes behind our digital world. Let's start with the basics. Binary is a base 2 number system. Remember how we count in our everyday lives? We use a base 10 system, meaning we have 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But in binary, we only have two digits, 0 and 1. These digits are called bits, which stands for binary digits. Think of a light switch. It can be either on or off, right? That's like a bit. In binary, on is represented by 1 and off is represented by 0. By combining these ones and zeros in different sequences, we can represent any number or letter. But why do computers use binary in the first place? The answer lies in the simplicity and reliability of binary. Computers are made up of billions of tiny switches called transistors, which can be either on or off. These two states are perfectly represented by ones and zeros. When a transistor is on, it represents a 1. When it's off, it represents a 0. This binary system is not only simple but also incredibly efficient for computers to process and store data. In the early days of computing, engineers realized that using a binary system would make it easier to design and build reliable machines. This decision has shaped the entire field of computer science and technology. Today, binary code is the foundation of all digital technology. From the simplest calculator to the most advanced supercomputer, everything operates on this elegant system of ones and zeros. So the next time you see a string of ones and zeros, remember that these tiny digits are the building blocks of the digital world. They translate into the numbers, letters, and symbols we use every day, making our modern lives possible. Now, imagine writing out a really big number in binary. Binary is a base 2 number system, which means it only uses two digits, 0 and 1. Every number, no matter how large, is represented using just these two digits. That would be a whole lot of ones and zeros, right? For instance, the binary representation of the decimal number 255 is 1111111. That's 8 digits just for a relatively small number. That's where hexadecimal, or hex for short, comes in handy. Hexadecimal simplifies things by using a base 16 number system. Hexadecimal is a base 16 number system. This means it uses 16 digits, 0 to 9 and A to F, to represent values from 0 to 15. So instead of just two digits like in binary, hex uses 16. This means it uses 16 digits, 0 to 9 and A to F, to represent values from 0 to 15. Why use letters? Well, after 9, we need single digits to represent those values larger than 9. So we use A for 10, B for 11, and so on up to F, which represents 15. This is why hexadecimal is often used in computing and digital electronics. It allows us to represent large binary numbers in a more compact and readable form. So, next time you see a long string of binary digits, remember that hexadecimal can make it much simpler. Why do we need these number systems anyway? You might be thinking, this is all very interesting, but why do we need to know about binary and hexadecimal? Well, my friends, these number systems are the backbone of our digital world. Computers use binary because it's the simplest way to represent information electronically. Remember the light switch analogy? Electronic circuits can be either on, 1, or off, 0, making binary the perfect language for computers to understand. Hexadecimal, on the other hand, helps us humans work with large binary numbers more easily. It's used in programming, web development, and digital design to represent colors, memory addresses, and much more. Let's dive a bit deeper. Imagine trying to read or write long strings of binary numbers. It would be incredibly tedious and prone to errors. That's where hexadecimal comes in. By grouping binary digits into sets of 4, we can represent them with a single hexadecimal digit. This makes it much easier to read, write, and debug code. This simplification is crucial in fields like computer science and engineering, where precision and efficiency are paramount. But it's not just about making things easier for professionals. These number systems also play a vital role in everyday technology. For instance, every color you see on a digital screen is represented by a hexadecimal code. This allows digital artists and web developers to create precise and consistent color schemes. Memory addresses in computers are also represented in hexadecimal, making it easier to manage and allocate memory efficiently. So whether you're coding, designing, or just using your favorite apps, these number systems are working behind the scenes to make it all possible. Understanding binary and hexadecimal not only helps you appreciate the technology around you, but also equips you with the knowledge to innovate and create in the digital world. So next time you see a string of ones and zeros or a hexadecimal code, you'll know there's a fascinating system at work powering our modern world. Embrace these number systems, and you'll unlock a deeper understanding of the digital universe we live in. And who knows, maybe you'll be inspired to create the next big thing in technology. The possibilities are endless when you understand the language of computers, so keep exploring, keep learning, and keep innovating. If you enjoyed this video, don't forget to like, share, and subscribe to our channel for more fascinating content.